I'm going to redeploy. What has happened? Did I spell something wrong? Incremented. That's good.
Is incremented called the first time that you load it? Because that should only because
it actually is called the first time, but let's.
Oh, you have to assign update to a variable. More update equals function.
Yeah, so that should still.
Oh, that is something like.
Oh, is it? Do I have to do something funny? Let's just check.
Brownie points for Patrick.
Thanks.
Cool.
Could it be? Right, let's move to one that I did earlier. Okay. Okay, let's move to one other thing, then I can move, then I can go to a contract that I made earlier. Okay, now, we'll make that work in a second, but before then, I'll show you inheritance. So, if we have foo, and actually let's not call it foo, let's call it owned. Has owner. Now, has owner is going to be a sort of property of a contract, right? Now what has owner is going to do, the idea of it is that it's going to record who created this contract, right? So the ID of the creator, and it's going to remember it, and it's going to allow you to restrict some of the functions, or maybe all of the functions, so that they can only be called by the creator. So this is useful for things that, for instance, have some user functions, like deposit, and some functions maybe that the owner wants to do, for instance, take all the funds that have been deposited, if you're a really bad bank. First thing to do with has owner is we need to record the owner. So what we're going to do is use address. Address is just an address of an account in the system. We're going to call the address owner. I'm just going to set owner to musk.sender. Musk.sender is just the person that sent us the message. So it's like the sender of the transaction that made this thing execute. Okay, in this case, for a constructor, it's just the ID of the account that issued the creation instruction. Now, the next thing is, suppose that we want our use case to be that within BAS, this increment function, well, it's only the owner that is allowed to increment it, okay? So we don't want to let anybody else increment. What we want to do is allow people to look at what the total is, but we don't want to let anybody just increment it, whoever they are. We only want the owner to increment it. So really, we want to be able to place a property, an attribute, with this function called onlyOwner, okay? Understood so far? And the idea of this is that only the owner of the contract can call increment. Yeah?
Now, is that a particular keyword in the system called only owner, or?
No, it's not.
Okay.
We're going to make this. Right. The first thing to do is to understand that we have another primitive. So we have events, we have functions, we have the fields, which is like the uint total, and we also have modifiers. Okay. This is a modifier. Oh, it doesn't turn red. I haven't updated the syntax highlight. That's a shame. So we're going to have a modifier. We're going to call our modifier onlyOwner. Okay? Now, modifiers, what they do is modifier onlyOwner. Oh yeah. What modifiers do is they allow us to rewrite the function that they are attributed to. So it's kind of like a rewrite rule. For what we want to do with only owner, well, it's quite simple. What we want to do is check that the owner of the contract is the same as the sender, or the caller of the function, right? The sender of the message. So this is a pretty easy thing to check. We do if message.sender is the same as owner, right? Understood so far? Now, then we want to have the body of the function that has been sort of modified by this. For that, we have a special word, we have a special symbol called underscore. Okay? Now what underscore means is put the function that we're modifying in there. Yeah, in this position. So basically move the abstract syntax tree, or this abstract syntax subtree, all of that code, and just hook it in here. In this case, it would be this code. Now the only thing we need to do now is to let Baz know that we are of type has owner, right? To do that, we just say is, that doesn't quite work, yeah, is has owner. And we see up here it's compiled without error, so it's happy. And what this is going to do is it's going to check that whoever was calling inc, basically it's going to turn this into if, I could just copy and paste. It's going to stick this code in here. Yep, understood. Good. Now, the reason I didn't call it owned is because there's actually already a one called owned. We have to import it. And we have to call this. And that actually works. So there are a bunch of sort of standard library kind of stuff that we can import and that we can use. And these include things like mortal, which allows it to be killed, and it actually inserts a kill function, so that the owner can then kill the contract when they want. And quite complex stuff like multisig, that basically allows you to say this function must have multiple 2 or 3 or 3 or 4 or whatever you want signatories going to it before it will actually execute. This is a fairly simple. Okay. There's one other thing I want to do. This is mappings. Now, one of the sort of perennial problems that we had with writing contracts in the system is in encoding the sort of data we want to store, the sort of state that we want to store within the contract. It's all very well to say, oh, well, I want a UIN that's total, and maybe I want an address that's my owner, and maybe, I don't know, maybe I want a hash of something that I'm interested in. That's easy enough, but what about when you want like a map of something or an array of something? Well, it so happens that we have another primitive called mapping. Now mapping is a way of creating a type that's a little bit like if anyone knows C++, it's a bit like a stud map. If anyone knows JavaScript, it's a bit like a JavaScript object, right? It maps from 2 arbitrary types. So what we could do is we could map from, for instance, address to uint. Now we might call this balances. Balance. Now what this allows us to do is to have a balance sheet. We take the address of somebody and we say, right, there's a number attached to it. It must be, it's unsigned, so it must be positive. We're not allowing anyone to get into any debt. And we're going to call this balance. And this would be basically a fundamental part of a subcurrency. The only other parts to a subcurrency really are probably something like be very bad and drain accounts. And it's only the owner that can call this, and it would just be basically owner.send. This dot balance, we actually don't need to put this in. Maybe we did need to put this. Its own, we have to import that. And total is 0, we don't need that anymore. an invalid type for an argument. Where's our argument? This balance. Send owner as fine. Send this. Let's suppose we know that there's 678 ether in the account. It's actually way. Then what we could do is drain the account. Now, the other point to a currency is, of course, to be able to send transfer balance. So we could do transfer, and of course we'd want an address to transfer to and an amount to transfer by. First, we need to check, of course, that the sender of the message that they have that amount in their account. So we just do balance. Sender. Greater than or equal to the amount, and if it is greater than or equal to the amount, then it's very simply a everyone understand that?
Does the underscore have significance right there?
Does the underscore? Oh, that's just my way of denoting. It's just my way of denoting a parameter.
Okay.
Balance, is that ether or is that some arbitrary balance?
Where are we looking? Oh, here. This is the balance in our. That's the balance in Gavin. Now, we might have an event called balance changed. And the event might have, for instance, a parameter. Let's call it might have several parameters. Address from, address to, and the balance UN amount. Okay, so events can actually have attached data. You can even index the data. What the indexing allows you to do is to search by it. And this works even for light clients. We actually spent a while designing this from the ground up so that light clients were able to actually know very succinctly and efficiently when events in particular contracts had happened on the blockchain. Obviously we would call balance changed when better label transfer. When a transfer has gone through, and then we just say, well, it's misc.sender that is sending, it's to that it's going to, and it's the amount that is being transferred. Okay.
So what the sender here represents someone who initiated the transaction to execute the contract?
That's correct. So misc.sender is the person that caused the initiate. Basically, it's the caller, right? So it's the caller of this function. That's the easiest way of putting it.
But it could be a contract.
But it could very much be a contract. We make no distinction. It comes from an account, but other than that, we don't know whether the account has associated code and therefore is probably being called by a contract, unless someone managed to solve a UID 256 reverse hash, or it's an actual person that's been signed. Okay, so everyone's understanding so far?
Like is message a special keyword?
That's correct. There are several special keywords in Solidity, one of which is message. It has, I don't know, sender, it has value, it actually has data. The data is actually, there is an ABI which allows the data to be interpreted and turned and dispatched into a function call. Because contracts get messages, right? Functions don't. So this notion of contracts having functions is something that we've added as an additional layer on top of what Ethereum provides. So we found, but this was basically from actually trying to write stuff and realizing that actually when I write a contract, often I want to do multiple things, which means I need an initial dispatch, like a big long switch statement. Hey, why don't we build this into the language? And hence you have an object-oriented style language. So yeah, there's a bunch of stuff. Must.send, must.value, must.data. I can't remember what the other things are. There's also TX if you want to get the original transactor. The person on the outside world, not any contract, who signed a transaction and pushed it into Ethereum. So you can get the transaction sender in the first place. What else is there? There's if you want to get stuff about the blockchain, we have block. Block.number is one of the useful things that you can get. You can also get block.blockhash. Okay? So what this is a function that allows you to give it a number for argument's sake. Let's call it block.number -1. And what this will return is a hash, which is the hash of the block that was mined. Sorry, it's the hash of the block that's the parent block of the one that this is in. You can't get the hash of the block of the one that this transaction is in because it hasn't happened yet. Because it hasn't been mined yet. When this code is executing, is while the block is being sort of compiled, and then it gets mined, and then you know the hash. So you can only ever get the hash of the last block to be mined. And that's why it's block number -1.
May I ask just a question? This may be just me. Where is the blockchain? Do you have a local blockchain in this scenario, or is this where is this? Which blockchain is this connecting to technically?
So in Mix, it has a local blockchain.
Okay, got it.
Yeah. So it's initially empty. I think it creates an identity. It gives us, I don't know, like 1 billion Ether or something, and then it creates the config and name reg and whatnot, and then the actual contract that you're developing, and then it allows you to do any transactions on it through the web interface. Okay. Cool. Are there any other questions?
Owner.send, that's independent of the coin balances, that's the contract's Ether balance?
That's correct. So what we're doing is sending to owner some amount. Oh, hold on, is this actually just this.send? Owner. So what we're doing is sending owner an amount of Wave. That's measured in Wave.
Yeah, so that's like the evil function in this contract.
This is the evil function. This is that they hope no one's looked at it.
Yeah, it's supposed to be a Gavcoin contract, but really...
It's actually, yeah, so that's my backdoor. In fact, let's just call it backdoor. Yeah. And what this allows me to do is just take all of the money out of the contract. Okay, any other?
I have a question. Sorry, backing up a bit, this may be a dumb question, but let's say you're executing code and it runs out of gas halfway through and you got to unwind everything. What if that code has already had side effects, like sending messages to other contracts and doing other things that kind of interact with the outside world, more or less? How do you cleanly unwind all of that? It's gone out.
The key problem is there is no more or less. Contracts cannot interact with the outside world.
Okay.
And therefore, any rollback is trivial.
Okay, so everything is self-contained until successful execution is
Correct.
confirmed. Okay, good enough.
Okay. Any other questions?
Is Mix currently stable and available? Can we download it, or?
It's definitely available.
Okay.
So a lot of this stuff was put in this morning by a nice guy called Arkady, who's busy bashing away in Berlin to try and get this thing stable. So yeah, we'll probably be releasing POC 8 in, I don't know, the perennial day or two. But when it's released, it will have Mix in it, and yeah, you'll be able to do some cool stuff.
Okay, but in the meantime, we can build it from scratch.
Oh yeah, sure. I mean, we have like not even nightly builds. We have like a build bot that just builds on demand. So
okay.
It's a bit of a pain. It uses like QML, Quick, so it's a bit of a pain to build sometimes. You need the latest version of Qt as well, like 5.4. But if you're happy going to the trouble, then yeah, it's good. It's there.
Thanks.
Other Questions so far? Right, now, I'd like to take you through a gambling contract. And this is an interesting one because it's it's like a two-part thing. So I'll give a bit of an introduction to how it's meant to work, and then I'll take you through the code. Right, how it's meant to work. Gambling contracts, we're assuming for this that the use case is that we have a person who comes along, what they want to do is interact with a contract. There is only one human user, okay? So we need a way, basically, that the person can be sure that the contract owner isn't in some way going to taint the outcome of the random event, right, that we're going to bet on. So one thing we could do is have a separate contract that just provided random data, and maybe we're quite happy to trust that, and the contract uses that. That would be one way of doing it. So having an oracle, basically, a random feed. Another way of doing it is to, if we have someone that we don't trust, is to do a commit reveal with them. So where we basically have a two-phase process, whereby we commit to something, we commit to sort of a number that we've thought of, and they commit to a number, and we don't know what the numbers are, but now we've committed to it, and there are ways of committing to it, which I'll show you, and then we both reveal at the same time. Maybe we add them together, or we XOR them, we combine them in some way, and that's our random number, okay? Another way of going, and the way that we'll go here, because that system only works when there's two people, and the first solution only works when we have a trustworthy random data feed. The way we're going to go here is we're going to use the blockchain as a random data feed. So one of the nice things about the blockchain is that it's got this proof of work, so it's got a hash. And it's very difficult to know what that hash is going to be up front. Now if you're a miner, you could potentially sort of look at when you get a valid hash, like look at it and think, oh, this isn't a good hash for this particular transaction, I'm going to throw it away. But by and large, it's probably fine. Certainly if the opportunity cost of throwing away a valid hash by virtue of, of getting a block reward is much less than the potential gains of having another go and getting a contract to win where it might otherwise lose. Okay. So we're going to use a hash from a blockchain, but we're actually going to also use a commit reveal process as well. So it's going to be sort of a sort of double whammy. Now, the basic use case, as I said before, is that someone comes along, they want to make a bet with a contract. For this, it's going to be simple. It's going to be a 50-50 bet, so it's like flipping a coin. Okay. We're going to bet that it's going to be it's going to be odds. So I've got odds or evens, right? So we're going to take the modulo 2, and we want it to be 1. Okay? So we're going to bet that some hash that we can't predict up front is going to be, when modulo 2 is going to be 1, rather than 0. Okay. This needs to be two-stage, because we're going to do a commit reveal. It also needs to be two-stage, because we don't know the block hash at the point of making the bet.